This video is designed to help you understand how to be given a couple of terms, from a geometric sequence, and to figure out what that geometric sequence is. In other words, what the general formula for that geometric sequence is, so that you could fill in the rest of the terms or find the 20th term or whatever. So suppose I tell you that a geometric sequence has the second term, which we'll call a sub 2, equal to 10, and the fifth term, which we'll call a sub 5, equal to 1,250. What this is telling you is that the geometric sequence looks something like this. There's the first one, and I'm going to label that down below a sub 1 because that's the initial term, which we don't know. But then the second term is 10. We'll call that a sub 2 as a reminder. Then we have a third term we don't know, a fourth term we don't know, and then all of a sudden we know the fifth term, 1,250. There's an infinite number of terms after that we could just keep going, right? Okay, so as a reminder, this is the fifth term, a sub 5. So what this is really telling us, since I've told you that it's a geometric sequence, if it's a geometric sequence, what that means is there was some number that we multiplied the initial term by, which we don't know, to get 10. And then we multiplied by r, that's our common ratio, to get the third term. And then we multiplied again by r to get the fourth term. And then we multiplied again by r to get the fifth term. What this is really saying is that if we took the second term, 10, and we multiplied it by r 3 times, we would get the fifth term. Now, that's just matching the idea that the common ratio is the multiplier each time. For each jump or step in this sequence, we had to get there by multiplying the previous term by r. So what we're looking for is r, and we have an equation that we can solve. This is 10r to the third equals 1,250. This allows us to simply divide both sides by 10. So if we divide each side by 10, divide by 10, we're going to get that, and I'm going to write it over here to have a little more room, r cubed equals 125. That's the ratio of the fifth term to the second term. So that ratio, instead of just being r, since it's 3 times that you used r as a multiplier, it's r cubed. So what we're really looking for is the cube root of 125, and the cube root of 125 is, of course, 5. So what that means is r is 5. So we know now that we have this general term, a sub n, is some initial term, which we don't know yet, times 5 to the n minus first power. That's our general formula for finding the nth term of a geometric sequence. So we figured out what r is. We know it's 5. So what we can do is take the information that we have, that the second term is 10, the fifth term is 1,250. We can take either of those. The easiest one is to take the second term as 10 and plug that information in. So if the second term is 10, what we have is 10 must equal a sub 1 times 5 to the 2 minus 1. Now, of course, 5 to the 2 minus 1 is just 5 to the first. And what we're really saying is that 10 is equal to a sub 1 times 5. I'm going to write 5 to the first. Of course, that means we just divide each side by 5. And what that tells us is that a sub 1 is 2. So now we know that our general expression here for this guy is a sub n equals 2 times 5 to the n minus 1. And that allows us to have the general form of this geometric sequence. So if we wanted the 10th term, we could plug in 10 for n and calculate what that term was. It's a large number and you'd need a calculator or take some time to do it, but it would be 2 times, so let me fill that in. So a sub 10 is 2 times 5 to the 10 minus 1, or to the 9th. Of course, that's a pretty big number. You can calculate it out yourself. Another way of thinking about how to find the first term is simply to say, look, we're looking at 10 here in our sequence, and we just want the term before it. Well, how did we get the term before it? We had to multiply by our multiplier. What's our multiplier? 5. So if we just take 10 and divide it by 5, we get that a sub 1 is 2, which we've figured out down below. Okay, I hope that's helped. I'm going to give you an example problem on the next slide, and you can work through that yourself. But keep in mind that if you're looking at a sequence and it's alternating positives and negatives, then your multiplier must be a negative number. Keep in mind also that your multiplier can be a fraction, which means you can be getting smaller each time. So there's lots of ways that it can kind of look a little funky, but with a little bit of practice you can do this. And this allows you to just kind of picture the sequence and follow each multiplier, determine what the multiplier is, and then determine the initial term. Okay? So here's a geometric sequence, and suppose I tell you that the third term is 1/2, or 0.5, and the seventh term is 8. So you could pause this video and try this for yourself, and then I will work it for you. So take a moment to pause. All right, so if you've worked on this problem, you possibly drew the sequence saying the first term, the second term, so I will write a sub 1 here. And the third term is 1/2. You could also write it as 0.5. And then the fourth term, the fifth term, the sixth term, and now the seventh term is 8. And I'm going to label each of these. I'm going to label this a sub 3 and label this a sub 7, so we've kept track. And what that's saying is we have one multiplication by the common ratio, another multiplication by the common ratio, a third, and a fourth to get us to 8. So we can simply write the equation 1/2 times r to the fourth equals 8. If we multiply both sides by 2, that's easier than dividing each side by 1/2. Let's multiply by 2, multiply by 2. That's going to get us that r to the fourth equals 16, which means r is the fourth root of 16. This is, of course, 2. And so what we're going to claim is that our formula for the nth term is something times 2 to the n minus 1. And now what we need to do is we need to find that something, which we're going to call a sub 1. So one way to do it is to look and say, let's just go backwards, and backwards again, divide by 2, divide by 2. So if we take 1/2 and divide it by 2, we get a fourth, and we take that and divide it by 2, we get an eighth. So in fact, we know that our general formula is 1/8 times 2 to the n minus 1. Now what we should do is double check that if we plug in 3 for n, we get that our third term is 1/2, and if we plug in 7 for n, we get that our seventh term is 8. So let's double check that. So if we do this with our check over here, we're going to get, for our third term, we're going to get 1/2. Let's check and see that we get 1/2. So we're checking to see if it is in fact 1/2. So it's going to be 1/8 times 2 to the 3 minus 1. So 2 to the 3 minus 1 is 2 squared. And 4 times 1/8 is 1/2. So in fact, that does get us the third term. And if we put in 7 for our term, we should get 8. So let's check and see if in fact we get 8 when we do 1/8 times 2 to the 7 minus 1, which is 6. 2 to the 6th is 64, and 64 times 1/8 is 8, and therefore that works. I hope this has helped. And just to make the point clear, we cheated a little bit to find a sub 1 by just backing our way out from a half down 2 steps. So we divided a half by 2 each time. You could have done it formally, once again, by plugging in 1/2 for a sub n, or a sub 3, right? And then plugging in 3 for n, and then solving for a sub 1. You can do that. You could also have plugged in for 8. Just as we checked, you could have also done those things with 1/8 missing and tried to figure out what a sub 1 is. It's a little easier if you visually just back your way out through the sequence, kind of imagining to yourself, oh, I'm going to divide a half by 2 and then divide it by 2 again. But either way is fine. You can do it formally or you can do it informally. Of course, if I gave you a to the 30th and a to the 50th, you probably want to do it formally rather than try to back out one step at a time all the way from a to the 20th down to a to the 1st. I hope this has helped.